Hi, everybody. Today, I'm going to be talking about deploying standalone Wolfram Language applications. So first, I'll just kind of talk about what are the problems generally when you're trying to create an application in the Wolfram language that's actually practical. So the thing is that it's not really possible to make truly distributable Wolfram language applications because of our current licensing restrictions. So, as you know, we have kind of math ID based ones that are kind of locked to your machine. We have kind of network, site licenses, and we have kind of lab passwords that, can, in certain cases, they can just kind of unlock the engine completely. But none of those are really a good fit for applications, because really what you want to do is just to have that application itself be licensed, so that no matter who you give it to, it's just going to run. And you're not completely, from our perspective, we don't want to completely unlock the engine. So that's kind of what I go into in the second bullet point here, right? People who are going to want to use your applications are going to need a license, and that's going to limit, your audience. And additionally, a big kind of hurdle for application developers is just the size of the language itself, right? Several gigabytes. And so if you're just creating a tiny little application, you're not going to want to induce, that issue. So additionally, personally, I think that, when you want to use the Wolfram language in kind of bigger systems, you're going to want to use, you're going to need some way to communicate to the engine, right? And so that's things like WSTP. But that's kind of this big, awkward, opaque, protocol that's can be a little bit confusing. And, it's a very Wolfram specific thing, right? In our own little ecosystem. So we want to kind of find some kind of alternative to that. And finally, we can't right now get an executable or a library from a Wolfram language code. You have to have an engine and then say, run this code here. You don't have just some code that can be ran itself as an executable. We have Wolfram script you may have heard of, and there's Wolfram script scripts, but you still need Wolfram script to run it. So I think that's a little bit of a issue as well. If you have any questions, just shout them out. All right. So like I said before, how we want to start fixing these applications is by licensing the applications themselves. Additionally, we actually want to make the kernel library, so in the layout, right, there's several layers down, there's a library subdirectory, and there's a libwolfram engine dynamic library. And that's where all the, kernel C code that implements the heart of the language, that's where that is, right? We want to expose an API in that library so that you can link against that. And then you can start building up expressions and evaluating them just by linking against that library. And that's what we see as kind of, people who are just trying to do the standard thing, you might want to just link against it like any other C library. So that's kind of what our idea there is. And it's important for us that how you deal with those expressions is very simple, and understandable. And right now it's kind of based on, in our kernel C code, right, there's kind of a certain meta language we have for dealing with expressions. So it's easy for us. So it's kind of based on that to an extent. Additionally, we want to make bundling the engine as easy and lightweight as possible. So, right, like I was saying before, if you want to bundle the engine, you're inducing all these several gigabytes. And additionally, just the workflow for that, for contacting us and getting approval to bundle the engine, that's difficult as well. So we want to streamline all those things. And that's kind of goes into my fourth point here. Ideally, we want a way for any Mathematica user to just take their code, go through some simple self-service workflow. So they're doing it themselves. They're not sending emails back and forth with sales, right? To get their application licensed and to start distributing it. And that's kind of our holy grail. And so, it's kind of like, if you can't really compile, just your arbitrary code, but maybe you can do the next best thing. And additionally, just kind of this isn't the standalone applications part, but in my department, engine connectivity engineering, we're trying to make building applications just easier generally. So we've got paclet tools for, that's kind of our, our unit for applications, paclets. So we're improving that. And then Brenton has stuff for, just kind of code development generally, code analysis, and all of these things are very useful. And as they get more mature, will be very useful for making applications. Alrighty, so I wanted to give some more details about what do I actually mean by licensing applications themselves. So, the core part of it is we want end users to execute approved Wolfram language applications, even if they don't have any license. There's no network license, there's nothing. There's no, lab password, which is, like I was talking about before, just kind of in certain cases can just unlock the entire engine. So it's important that the unlicensed engine can only execute the approved applications from our perspective. But if you disagree, tell us. And like I was saying before, in typical cases, you'll just be able to walk through it yourself. And this is something that I thought was important, but maybe other people won't. But like when we looked over leads for like potential people who wanted to create applications, a lot of times they didn't have internet access. They were deploying it on certain, there was one example, people wanted to put it on like amusement park machines when you're paying or something, and that doesn't have internet access. And so if it has to come and talk to Wolfram Research and say, am I licensed? That's a difficulty. Or, if you're in some kind of sensitive context, you don't want it to phone home. So we want to make that possible as well. And so there's kind of a bunch of things like that that are holding people back from making applications that we want to address. All righty. So this is more on the making the kernel linkable idea, which is what I was talking about before. We're kind of just linking against the kernel, like any other C library. So this is kind of the technology that allows us to create these application executables and libraries. If we didn't have that, we wouldn't have any way to link against the kernel and run code. And so that's kind of the core technology. And it's a little bit, it is a little bit kind of a cognitive, burden. So in the default, typical cases, you might not have to use this, right? But this is just some underlying technology that we're adding and that some people might find interesting, right? And of course, one of the biggest parts of this is, right, it's just the kernel runs in your process. It's not like WSDP where you're starting another process and saying, talk to me. And then what exactly we're doing with the expression API will become clear as we go on. And then I give a little bit more about bundling the engine here, right? And so something that's important to us, because I keep talking about the size of the engine, several gigabytes. We want, depending on what your application does, your application is not going to be using, probably won't be using all of that. So we want to say, what are you using, and take out what you're not to try to reduce that size burden for your application. So that's another big feature. And then, here's another crazy holy grail idea, is the potential for truly standalone applications and libraries. So this, what I'm talking about before was that you have some kind of application binary, and then there's also a layout that needs to come along with it. So that's a directory. But it would be really nice if you could just have an executable or just have a library, and somehow that would work. And so we were thinking, maybe it extracts out, paclets in the layout into some kind of, persistent directory, so that when you're distributing it, you're not distributing a directory. But that is, just something we think would be useful. So we're not taking it off the table yet. All righty. And so what's the actual workflow for, oh, sorry, go ahead. Yeah. Yeah, so again? Yeah, so with regards to the front end, for this, for the first phase of this, we don't imagine much, you're not creating actual front end applications, but we do think, maybe you can rasterize things, having some kind of stripped down rasterizer. But the point here is a language runtime, all right? It's not the front end. We want the actual language to be supported and distributable, So by printing, what do you mean? Yeah, so that's something that you can configure. If you did print some string, depending on how your application, that's, do you want it to go to standard out? If you want to, it will. And so that's kind of part of the expression API thing, because that's how we're turning the kernel into a library that can actually be used by third parties. All right. So we imagine you start with the code you want to turn an application into, a paclet, a script, a source file, anything that your application can come in, right? And so we imagine that we'll have a command line tool and a top level Wolfram language function for kind of starting to process your application. And that we'll try to make that as easy as possible for you. And then you have to kind of determine, do I want an executable that just runs some code, or do I want a library that I can call into? And so when we say a library that you call into, what that actually means is that you're going to have a paclet, and you're going to define several functions in it. And when you're deploying that library, you're choosing what Wolfram language functions you want to see exported in the library that we're producing. So, if you've got a paclet that defines some function random string, when you start processing that, the output that you want from our automatic process that walks you through it is just a dynamic library that exports that random string function, and then you can call into it, and we're going to use our internal code for linking against the kernel to call the language and things like that. And so just another kind of subtlety to this is that you are choosing the signature that you want the dynamic library function to be. So if you have it as LSC types, we're going to automatically convert to expressions. But what the expression API allows you to do is have kind of a language in C for dealing with expressions themselves. So you can select that I want to call this function with an actual expression. I want to return it as an expression. I want to interact with it as an expression. And so, I might not have time to demo that now, but if you come to our roundtable, I can. And that's kind of what I was talking about with configuring the executable library. For the library, you have got to select the functions you want to export. For the executable, if you just have a single file, well, then, maybe that's pretty easy. But sometimes you might want to select the function that you want to enter into, where the executable is starting from. So there's going to be all kinds of settings. All righty. Yeah. And so I keep talking about bundling the engine, but you might not necessarily actually want to do that. That you might expect that all your users are already going to have it installed. And if that's the case, then you can say, I don't want this engine. And we're going to use kind of a different technology. We're going to automatically discover the installations that are already available on your end users' machines. And we're going to find them out. And that's what we're going to be using in order to run your application. And so this is kind of what we can call in the JRE model, right? So you can it's kind of like CDF, and you're just saying, go download this, but it's not something as specific as that. You just download any installation, and that's gonna be enabled to work for these applications. And if you are bundling the engine, then we have to figure out how to prune your engine down for your application, right? So that's going to be, to some extent, that'll be automatic potentially, but you're going to need part of it. And then if you are releasing your application, we're going to walk you through the licensing process for licensing your application. All right, so what's the goal of this talk? We want to just tell you how we want to see kind of a new way of doing application deployment. And we think it will be pretty useful, but what do you think? And I kind of talk about what exactly we're asking for here. And we want you to go to our roundtable so you can talk to us directly. And that's at 4 p.m. And if you have any comments that you don't want to do now, you can send an email to me. And then this presentation will be available somewhere, so I'm sure you can find that email. All right. We're going to go a little bit technically into, how developers' applications are licensed. So we're generating signatures for your source code. Now, they're not really true signatures. They're, Wolfram Research will hold the private key. And that's what's going to be used to generate these signatures for your source files. And the engines will have the ability, to decrypt the signatures and verify them against your files. So that's kind of what we mean. And what exactly is signed? Well, it's basically Wolfram language code. So if it's a WL file, if it's a .m file, if it's an MX file, that's going to be signed. And so it's not just your application, it's also the layout. So if you tried to change something in the layout, hopefully we would catch that as well. So it's kind of just a way for us to get away with deploying applications. Yeah, and so our tools will just, when you're deploying the application, will find these things and sign them for you. Yeah. All right. And so, that's going to require a submission to the Wolfram Research, and they're going to sign for you. But once you have those signatures stapled to your application, which is how it works, that will make it truly distributable. So when we talk about bundling the engine, and we talk about how large this thing is, what actually takes up so much space, right? So I was looking at the size of the Wolfram engine, right? And so, a lot of it's MKL. A lot of it is, front end things, auto completion data. A lot of it is, some compiler stuff like compile. So there's a lot of things here, and a lot of times you're not going to need them. You're not going to need WSDP, which takes out that big chunk. You're not going to need every MX startup file. You don't even need MKL because we can use different BLOS backend. And you probably won't need auto completion data. So there's lots of strategies for us to actually really productively take down that size. So like I was saying, switching from MKL to OpenBLOS, you're taking, you're getting less when you do that. But if you really care about size, then this might be acceptable to you. And in the engine, people get shocked by that big size, but not all of it's actually functional, right? We have documentation, we have examples, we have SDKs, which is what that WSDP thing was, right? It's just a code in the layout for you to start creating WSDP applications. But if you've already made your application, you're not going to need that. And then removing front-end dependencies, because this is just supposed to be a language runtime and not a replacement for everything that Mathematica is. Yeah, and so additionally, those are kind of broad strategies, but we also want to prune specifically to what your application needs. And so we kind of envision several types of way this would work. Right now, we have kind of a dynamic analysis where you run your application and we catch everything that you access, and things that are not accessed most of them will be pruned out. And this is how we're doing like a guess of what you don't need, And so if you wanted to get that guess, you would kind of run your application underneath this kind of pruning harness. But that might not be perfect. And if it is not perfect, we also have kind of a manual way of dealing with pruning that you would use, and you would select what you don't actually want pruned. And then we also want to do some kind of static analysis based on just the code of your application, try to figure out what you need without actually running it. Of course, the most concrete one of these right now for the project is that dynamic analysis. All right. The binaries that we produce, because these are the applications, this is basically what we're processing your application into. The expression API, like I was saying, is basically the core of it. When you write your code, the expression API is how we're going to be loading it. And so there's actual API functions for reading in files, for evaluating strings, all that kind of thing. That's how the expression API works. And so when I was talking about the libraries that we're producing earlier, and you're exporting some Wolfram language function, how are we actually going to call that Wolfram language function using the expression API? We're going to construct an expression call using the expression API. And that's internally how we implement that C function that we're exporting. If you had that, like I was saying, random string, we're going to have expression API code that calls into the Wolfram language and does that evaluation. You're not doing that. We're doing that. It's going to just be something that's automatically generated, but that is technically how it would be implemented. Now, there are some signing issues with the expression API as well. Since the expression API opens up a new way to talk to the kernel. And so we can't just let you do whatever you want, presumably, because that defeats our signing mechanism. You could just type, code whatever you wanted that called into the expression API and just do kind of arbitrary things that haven't gone through this application deployment process. And so our solution to that is expressions with heads that are signed are the only expressions that can be evaluated. And so what do I actually mean by that? The example of the library, as part of the signing process for the application, that random string Wolfram language function is also a signature is generated for that as well. And that tells the expression API that you can construct an expression call that uses that function. But we're flexible with this. If you wanted to sign some system symbol, or if you wanted to sign some other things, we would of course be open to that. This is just kind of the basic workflow. And what I mean by signing a system function is if you wanted to, right now, important system functions that carry a lot of functionality are not something you could use in the expression API with an unlicensed engine. With a licensed engine, you can do whatever you want, but with an unlicensed engine, we're going to prevent you from doing that evaluation. And just one final note on this is that we do still want it to be convenient to use the expression API with unlicensed engines. So kind of certain innocuous system functions will go through with the expression API. All right. And so this is pretty much the end of it. But if you wanted some kind of details about what actually takes up the space in the engine, this directory in the layout, it takes almost a gigabyte if it's MKL, right? Which is crazy. Links as a whole takes up almost a gigabyte, so you can kind of see where all that space is going. Yeah, and I was talking about that earlier, but you were saying you just delete all of WSTP. Put WSTP in there, right? Because WSTP.a is like what, 50K? I know that's probably, but it's not more than a couple of megabytes, right? The reason that directory is so big is the pre-built example. Yeah, I think that's part of it, but I've seen a lot of in links. I've seen a lot of big libraries as well, right? So I thought Mathig was like 10 megabytes or something. So, I guess that's in between, but I think you still get there's a lot of purchase that you can get even after you've pruned out those things, just because of, in certain cases, those libraries are pretty big that we're using, but maybe not for most cases. All right. So I can kind of just show you a little bit, maybe this will just be more confusing than clarifying, but these are the kinds of things that when you're linking against the kernel, these are the functions that you can use. So there's a C function for creating a symbol, right? There's C functions for creating normal expressions, all kinds of things. Let me find evaluation, right? And then there's ways to kind of deconstruct expressions, integer data. If you have an integer expression and you want the C version of that, you would use something like this. So basically, we just want a C API of expressions. All right, more expression API stuff. All right. So I was wondering if anybody had any additional questions. Yep. Yeah. So every time an API function returns an expression, that's associated with what we're calling an expression pool. So you create these expression pools to kind of deal with expressions, in a series of, in kind of a certain context, to deal with their memory as a collective. And so, we think that'll be more convenient than just managing every expression's memory individually, especially because the way the expression API works is that it's very easy to chain, how you're dealing with these expressions into a single line. So like I can give you an example here. All right. So if I did, right, so this is that. Right, so when we say E, maybe this isn't the best word for it, but this is our normal expression. And so since we have just the first argument here, right, what that actually means is just a normal expression with that head and no child elements. But you see how this chaining happens? In doing this, you've created a whole bunch of expressions. You've created, right, you've created G, the symbol G, you've created this normal expression, so that's a whole bunch of expressions, and you're not it would be less convenient if you had to manage the memory of each of these sub-expressions. So we want to make it possible to have these expression pools so that you can still do coding like that. And so that's how, there's functions for releasing expression pools. These expression pools can be nested. And so, one interesting scenario might be just you have a function that does some evaluation. You can create an expression pool for that function, right? So that's just kind of like a particular context for whatever you're doing with the Wolfram language. And then say you have one expression that you're returning, you can promote that expression out of your expression pool, and you can, bring it up to the higher level. And so everything else, all the other, temporary stuff that you have laying around, you don't need that any longer, but you will just have that one thing that you're returning will still survive. And there's kind of more details to this as well. You don't always have to use expression pools. You can release expressions individually if you want to. You can detach expressions from these expression pools so that you release them, manage their memory individually as well. So there's options. Yeah. Yeah, well, the API underscore is a temporary thing, but we're probably still gonna, since it's C, we're probably still gonna have that prefix. It's just gonna be a better design one. Well, it's a C kernel, but maybe we could. I mean, we want people to be able to use it from C as well. Yeah, so I think we want it to be as simple as possible.
Right. So the only thing
Yeah. 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 So maybe we can have two, right? We can have the C API and we'll have the C++ API. Yep.
What sort of time frames are we talking about?
Well, that's a good question. If you come to the roundtable, we can demo what we have, but some of these other parts of the project that we were talking about, like that workflow, like the thing that involves some service that signs your code, that's all web development stuff that isn't done. So to some extent, it's a unknown, but we're hoping matter of months or something like that.